Hello, welcome to the fourth assumptions about regression diagnostics in Stata, and that is independence of the error term. The assumption is that the error term should be independent across unit and across predictors, and that is the X variables. That means that the errors for the different observations should have zero correlation. This is more likely to be the case in cross-sectional data than in panels or time series. In time series or panel data, we have the observation coming from the same person over time. So therefore, we can expect correlation between the errors for the same person for the different years. Okay, when we have this assumption not being met, then we have a problem called autocorrelation. That means that we have dependent errors. The errors are correlated with each other. And this is more likely in panels or in time series. And what are the consequences? We have underestimated standard errors, just like we had for heteroscedasticity problem in the previous video. And that leads to inefficient coefficient and consequently invalid hypothesis testing. How do we test for autocorrelation or non-zero correlation in Stata? We can use the Devin and Watson 1950D test for pool OLS model and also for cross-sectional. And we use the D-test, which is a function of the number of observations we have and the number of parameters, that is the number of independent variables. And then we use the table provided by Devin and Watson. And we have two values to look out for. We have what we call the lower bound and then the upper bound values. So if the value we get on the D-test is less than the lower bound from the table, then we reject the null hypothesis of no autocorrelation. Ideally, from the table, if we have a value around 2, then we don't have a problem of autocorrelation. But then if you have more than 2, then we have a problem. But then you use this rule of thumb that if the D value is greater than the upper bound, then we reject the null hypothesis. For panel data, you can use this user-written command called xtserial, and you have to install this before you can use it to check autocorrelation in panel data. And the assumption remains the same of no autocorrelation or no first order correlation. Now we're going to use this data set provided by Klein 1950 to regress consumption, which is our dependent variable, on government wage. We want to see whether national consumption is being influenced by government wage bill. All right, and we will use this post-estimation command, start Watson. And then we just look for the critical values for D, and then we will conclude whether we have a problem or not, autocorrelation problem or not. From this analysis, we will conclude that we have autocorrelation problem, and therefore we reject the null hypothesis. But then let's look at how we come to this conclusion in Stata right away. Let's get to Stata and do that in practice. So I have my Stata open, and I already have my do file. And as I said, we are looking at the fourth assumption. That is independent errors or zero autocorrelation in our model. We're going to use the data set, as I said, by Klein. So just type web use Klein, and you will have the data set loaded. Okay. Here you can see I have that loaded now. Next, I will tell Stata that this is time series, so time set. Okay. a year, and then you see from 1920 to 1941. Then now I'm going to run the model. So this is just pool OLS. So we say regress consumption on government wage. All right, here we have the result. We are not interested in this. We are interested in whether we have autocorrelation or not. Then I'll just type a stat D worsen. Okay, we have the D statistics to be 0.32, and then as I mentioned, we have two parameters. Then we have two parameters here, so including the constant term, and then we have 22 observation, which you can find below the data set here. All right. Now we conclude that. How do we conclude? We look at the table. We look at the D table. So here is the D, Devin and Weston significant table. Here we look for 10%. So here are the rule of thumbs, but we are not interested in that. You can read that yourself. You can get this table from Google. I'm looking for table 2. Here we are looking at 5% confidence level, and we have the D level, the lower bound and upper bound. Now, if you consider the intercept as one of the parameters, then we will look at 2. K is 2, and then we look at how many observations. We have 22. So across here we have 1.4. 1.14 and then 1.5. This is lower bound and upper bound. And I said if the we go back to the slide, we have to conclude, we say that if D is less than, okay, if D is less than the lower bound, then we reject the null hypothesis, all right, of no autocorrelation. And if D is greater than, we accept. So here D is not. So D is less than 0.32, is less than this lower bound. So we reject the null hypothesis of no autocorrelation. So we conclude that we have autocorrelation problem in this model. And this is how we end tested for autocorrelation in Stata. Next, we will discuss multicollinearity problem in Stata.